Hello, this is Mr. Stein, and in this video we are going to get started on section 6.4, the slope-intercept form of the equation of a linear function. So we're looking at a polynomial function that is linear. We're looking at the slope-intercept form. By the time you're done this lesson, you should be able to graph a linear function of the form y equals mx plus b, determine the equation in y equals mx plus b form given a graph. Remember, always going two ways. Given the equation, determine the graph. Given the graph, determine the equation. Convert other forms of equations into the slope-intercept form, y equals mx plus b. Relate the equation of a graph to a real-life situation. All right, so here we have the slope-intercept form, y equals mx plus b. It's right here. And our m, the m stands for the slope. And the b stands for the y-intercept. Now, m and b, both m and b can be elements of the real numbers. So we can have decimal values or anything. But most of the time, when we work with our slopes, we are going to be working with rational slopes, so fractional slopes. And for the most part, just for our ease of use, we're going to use our y-intercepts are going to be generally integer numbers. All right, so if you ever see this type of an equation right here, you know that this is going to form a linear equation. This is called a degree 1 equation. The reason it's called a degree 1, it's a degree 1 polynomial. Because the largest exponent on our variable is 1. So our largest exponent on a variable is 1. And it's linear because it goes in a straight line. All right, so we've got some examples here. We're going to identify the slopes of these, then we're going to identify the y-intercept, and then we're going to quickly graph them. So our first one, I'm going to do in orange. Our slope is 2. Slope is 2, and our y-intercept is plus 1. Now remember, when the slope is 2, that means it's 2 over 1. That's a rise of 1 and a rise of 2 and a run of 1. So when we graph this, we start off, we look at our y-intercept. I generally put that on first. And then I go by my slope. It's positive 2, so it's going to go up 2 over 1, so right there. And I usually put on a few of them just to help me draw it out freehand. And you can even go backwards. Put a line through it. Arrows on both ends because it goes both ways. And we label it y equals 2x plus 1. Let's look at our second one right here. Let's identify our slope. Our slope is right here. It's negative 1/2. That means we're going to go down 1 over 2. Remember that the negative sign, we can just apply it to the numerator. Down 1 over 2. And then our y-intercept is right here at minus 2. So I start off by putting my y-intercept on. That's what I do first. Then I look at my slope. It's being down 1 over 2, down 1 over 2, down 1 over 2. I can go the other way, maintaining the same pattern. Draw a nice straight line through all those dots. Put arrows on it and label it. Notice that these two are perpendicular. They're negative reciprocal slopes, so they're perpendicular lines. Now let's look at our third one. What's missing in here? It does not have a y-intercept. We know that the slope is equal to 2/3, but our y-intercept isn't there. Well, we can just say that that's the same thing as adding 0. So our y-intercept is actually 0. So it goes through 0 right here. So if you don't see a plus a constant, this term is called a constant because it doesn't have any variables with it. If you don't see that adding or subtracting a constant, it's the same thing as adding 0 to it. Or subtracting 0, it doesn't matter. Plus or minus 0 is the same thing. So we start at 0, and this is going to be called a direct linear function because it goes through 0, 0. And we go up 2 over 3. Up 2 over 3. Right here, there's our slope. Up 2 over 3. Up 2 over 3. And you can work it backwards at the same pattern. Draw a nice straight line through it. Label it y equals 2x, 2/3 x. Now, will you ever see something like this? Y equals 0x plus 5. What does this mean? Well, this means it's not going to have any slope. No slope. But it does have a y-intercept, and this graph is going to look like this. We're going to have a y-intercept, and then we're going to have no slope, so it's going to be just a flat line. Y equals 0x plus 5, which is the same thing as saying y equals 5. All right, so you should be able to take a function in the form y equals mx plus b and graph it quickly and easily. Now, we're going to take these three and we're going to convert them into slope-intercept form. When we're converting functions into slope-intercept form, that means we need to isolate y. So let's look at the first one, and our goal is to isolate y. So first thing we're going to do is take away 4x from both sides. So we're going to get 2y is equal to subtract 4x plus 18. I just put my negative 4x first. Okay, now this is looking more like y equals mx plus b. Then we divide both sides by 2. When we divide a whole side by 2, each term in the polynomial has to be divided by 2. So I'm going to end up with 1y is equal to negative 2x plus 9. Then you can see our slope is negative 2, our y-intercept is 9. So if you're converting something into y equals mx plus b form, you need to isolate y. So look at this next one. We need to isolate y. Now, I'm going to do a little something here, just because I like to. I'm going to add 3y to both sides. This gets more things to be positive than negative. So I'm going to get x equals 6 plus 3y. Then I'm going to take away 6 from both sides. I get x minus 6 is equal to 3y. Now, finally, I have to divide by 3, and I have to divide everything by 3. So I'm going to get x over 3 minus 2 is equal to y. Now, this is y equals mx plus b form. The only thing is, we don't like this guy right here like this. We want to change that around a little bit. So we take the x out of the fraction. And x divided by 3 is the same thing as saying 1/3 x minus 2 is equal to y. Now this is much easier to see. You can see that 1/3 is our slope and minus 2 is our y-intercept. All right, let's look at our last one. 3x minus 2 is equal to minus 2y plus 7. All right, so first thing, subtract 7 from both sides. So you get 3x minus 9 is equal to minus 2y. Now I need to finish isolating y, so divide everything by minus 2. Divide everything by minus 2. And we are going to get y on my right-hand side. Those cancel out. And 3 over negative 2x plus 9 over 2, right? 3x over negative 2, will give us that. And then negative 9 divided by negative 2 will just give us 9 over 2. Now, I can leave this as fractions because for me, for the slope, working with fractions for slopes makes slopes easier. I'm just going to rewrite it as negative 3 over 2x. Remember, we can do that. For our denominator is negative, we can just switch our numerator to negative. I'm actually going to change this guy to a decimal because why not? I mean, actually, y-intercepts work nicely in decimal forms. All right, so I hope this was helpful for you. You should understand what the slope-intercept form is, y equals mx plus b. You should be able to quickly graph functions in the form y equals mx plus b, and you should be able to convert other linear functions into y equals mx plus b form. If you